We can have a mole of cars or a mole of houses, but this unit measures large amounts of small substances such as atoms or molecules. The mole can also be defined as the amount of substance which contains the same number of particles as 12 grams of carbon 12 atoms, which again is 6 times 10 to the 23. Because the mole deals with quantities, this topic has a lot of calculations present. And the first that we'll look at is how we can determine the number of moles if we know the number of particles present. From the definition of the mole, we know that 1 mole contains 6 times 10 to the 23 particles. Particles may mean atoms or molecules, so if we hear these terms, just remember that we're talking about the same statement that says 1 mole contains 6 times 10 to the 23 particles. Let's look at our first example. Calculate the number of moles present if there are 12.9 times 10 to the 26 particles. In order to do this, we would cross multiply in order to solve. And by cross multiplying, we would do this. And the result would be x times 6 times 10 to the 23 is equal to 1 times 12.9 times 10 to the 26. We would then solve for x, which means we would divide both sides by 6 times 10 to the 23 and say x is equal to 12.9 times 10 to the 26 divided by 6 times 10, 23. Now there's a video that is shared on Edmodo. Ensure that you watch the video to see how you put these numbers in your calculator. You'd never ever ever type times 10 in your calculator. There's always an exponent button that shows you that would represent times 10. So it could be EE or EXP. When we put this in the calculator, the answer is 2,150 moles. Remember to always add your units at the end. We're calculating number of moles. The unit for mole is MOL. Let's do a second example. Calculate the number of moles present if there are 50 times 10 to the 12 particles. So again, we would start by writing the first statement. 1 mole contains 6 times 10 to the 23 particles. And then we'd write a second statement based on the question that's given. We don't know how many moles, so that would be our unknown x. And we'll say x mole contains, from our question, 50 times 10 to the 12 particles. We would then cross multiply and the result would be x times 6 times 10 to the 23 is equal to 1 times 50 times 10 to the 12. When we solve for x by dividing both sides by 6 times 10 to the 23, we would get x is equal to 50 times 10 to the 12 divided by 6 times 10 to the 23. And once we put this in our calculator, we would get 8.33 times 10 to the negative 11 moles. Once again, we'll start by writing the statement which says 1 mole contains 6 times 10 to the 23 particles. Then we'll write a second statement where x is our unknown number of moles. And we say x mole. We'll write a second statement saying x mole contains, from the question, 3 times 10 to the 24 particles. Once we have both statements, we cross multiply, and the result would be x times 6 times 10 to the 23 is equal to 1 times 3 times 10 to the 24. Again, we would solve for x, which is our number of moles. X is equal to 3 times 10 to the 24 divided by 6 times 10 to the 23. And our answer would be 5 moles. If we can find the number of moles from the given number of particles, then we should also be able to determine the number of particles if we know how many moles are present. Our first example says that we should determine how many particles are present in 1.7 moles. Again, we'd start with our statement. 1 mole contains 6 times 10 to the 23 particles. But this time we do know how many moles we have. 1.7 mole contains, and this time our unknown is a number of particles. So our x would go here, contains x particles. We would again cross multiply, and the result would be x is equal to 1.7 times 6 times 10 to the 23. 1.02 times 10 to the 24 particles. Let's do another example. Let's do a second example. This question says how many particles are present in 3 times 10 to the negative 3 moles. We know how many moles are present, so we'll start by writing 3 times 10 to the negative 3 moles contains x particles. Cross multiply, and we would get x particles, or x is equal to 3 times 10 to the negative 3 times 6 times 10 to the 23. When we put this in our calculator, our final answer is 1.8 times 10 to the 21 particles. If we knew that one iPhone has a mass of 5 grams and we were asked to find out the mass, find out how many iPhones are present if the collection weighs 25 grams. To find out how many are actually there, we would divide 25 by 5 and we would be able to tell that we have 5 iPhones. Same is done here. We have the mass of the entire substance that we have weighed out, but if we know the mass for 1 mole of this substance, then we can divide the given mass to tell how many moles are actually present. In order to find our molar mass, however, we need to know the mass of each atom, and these masses come from our periodic table. Now, a few examples are on the right. If we wanted to find the molar mass for a single atom, then we'll just use the number as is. So the mass of hydrogen is 1, mass of carbon is 12, and so on and so on. Let's look at our first example. Calculate the number of moles in 12 grams of oxygen. So we want to find mole, and we'd say mole is equal to the given mass, which is what they tell us in our experiment, is equal to 12 divided by the molar mass of oxygen, which is 16. When we put this in our calculator, then the answer would be 0.75 moles. Our second example says calculate the number of moles in 5 grams of sodium metal. Now here we see that they ask us to find the number of moles in 18 grams of water. Now water is not an element, so we can't simply pull the mass from the periodic table. We'd have to actually calculate the molar mass of water. And we do that by adding the mass number for all the atoms that are present in water. The formula for water is H2O. And in order to find the molar mass, we'll add the mass numbers for every single atom. Now the mass of hydrogen is 1, but there are 2 hydrogen atoms, so we multiply that by 2, and we have 1 oxygen atom, so we would add 16 to that. So the molar mass of water is 18 grams per mole. Mole is equal to the given mass, which is 18, divided by the molar mass, which is 18. So the number of moles would be 1 mole. The number of moles in 0.8 grams of oxygen gas. First, we have to identify that oxygen gas is not an atom. And to calculate the number of moles would be equal to 0.025. The given mass, which is 0.8, divided by the molar mass, which is 32. We put that in our calculator. Final example to calculate the molar mass of a substance and hence the number of moles of that substance. 0.025 mole. We need to first find the molar mass of sodium hydroxide. Final example to calculate its formula is the molar mass of a substance and hence the number of moles of that substance. Let's do a final example to calculate the molar mass of a substance and hence the number of moles of that substance. Its formula is NaOH. And again, we need to add the mass of every single atom present in sodium hydroxide. The mass of sodium is 23 plus the mass of oxygen is 16 plus the mass of hydrogen is equal to 1. So sodium hydroxide has a molar mass of has a molar mass of 40 grams per mole. Once we have the molar mass, we can go ahead and use our formula, which says that the mole will be equal to the given mass, which is 1.3, divided by the molar mass, which is 40. When we put that in our calculator, the answer that we would get is 0.03 moles. If we are given the number of moles and are asked to find the mass of substance, then you would have to transpose this formula. We will do so by multiplying both sides by molar mass. So given mass would be equal to number of moles times molar mass. We would then substitute our values into our equation and we would solve to find our given mass. Let's look at this question. It says, how many atoms are in 5.6 grams of magnesium? No, we don't have an equation or a statement that directly links atoms, number of atoms, to mass. The common thing with both of those, however, would be the number of moles. So if you are presented with a question like this, the first thing you need to do is find the number of moles before you can solve for what the question is asking you for. So we do know the mass of the substance. So we can find the number of moles by using the formula mole is equal to given mass divided by molar mass. The given mass is 5.6 and the molar mass for magnesium from our periodic tables would be 24. The number of moles in this case would be 0.23 mole. Once we know the number of moles, then we can go ahead to solve for the number of particles, the number of atoms. We'll start by writing our statement, which says 1 mole contains 6 times 10 to the 23 atoms or particles. Therefore, 0.23 mole contains X particles. We would cross multiply and X would be equal to 0.23 times 6 times 10 to the 23. The final answer would be 1.38 times 10 to the 23 atoms. Now it could be asked the other way as well, where it gives you the number of particles and you should find the mass. But once there is no direct link between the two quantities in a question, know that you must first find the number of moles before you can move on.